All right, so we're gonna go through some practice problems where we're gonna figure out what the domain and range of each of these graphs are, and then we're gonna write whether or not the graph represents a function. So this first one, we got this circle here, and with the circle, you have several points on it, let's say here and here, where you have the same x value, so 0 and 0, but different y values. Here x is 0 and y is 3, and here x is 0 and y is -3. So this would not count as a function of x because you have x values with multiple y values, and that's not okay. So not a function of x. But let's go ahead and now write the domain. So the domain is, remember, the set of x values. So let's look at this from left to right. So from here to here, essentially, from left to right, will be the domain. And the leftmost point is at -3, and the rightmost point is at 3. So the domain is a set of x values from -3 to +3. And we're going to put a bracket because we include those values, -3, comma 3 with brackets around it. Now the range will be the set of y values that this graph takes up. So it'll be the vertical, I guess, interval. So, let's go from here up to here. This will be the range. And down here, the y value is -3. And up here, the largest y value is 3. So coincidentally, the range is also the same. The range is going to be the set of y values from -3 to +3, including those numbers. So we're going to put brackets around it. That's our domain and range. All right, the next one we have this linear graph. And these arrows, these are supposed to be arrows showing that it's going infinitely in that direction, that direction. And since we have a linear graph, that's slanted, this would be a function of x because there aren't any x values that have multiple y values assigned to them. So function of x. And now let's write down the domain and range. The domain would be, again, the set of x values that this graph would, take up, the set of x values that this graph, it spans. And since it goes infinitely in that direction, this direction, the domain are all the real numbers because it goes forever to the right. If we were to go, in this direction, we would, keep on increasing in x. And if we kept on going to the left in this direction, we would keep on increasing in the negative direction. So domain, are all the x values. So to the left direction, that will be going towards -infinity. And to the right, that would just be +infinity. So the domain, we would write the domain goes from -infinity to +infinity. And we're going to put parentheses around those because we can't include infinity. Because infinity is technically not a number. It's basically like we say it's a behavior of a number. And you can also write, the set of all real numbers if you want. The range, likewise, is the up and down. And, it does essentially the same thing because it's going to infinitely go up and infinitely go down if we, kept on extending the line. So the range is also all the real y values. So -infinity down here to +infinity upward. So the range would be the same as the domain, except we're talking about just y. So from -infinity to infinity, and we use parentheses because we can't include infinity. All right, problem C. Right here we have a graph that ends over here. So it stops at this point, which is at -4, or no, -2, -4. And this point is at 4, 2. So this would be a function of x because again, we have no x values that have more than one y value assigned to it. So function of x, that's good. And the domain, we look again at the set of x values this graph takes up. So going from the leftmost point to the rightmost point. So from here to here, that would be our domain. So the leftmost point, or leftmost x coordinate is -2. and the rightmost x coordinate is over here at 4. So the domain will be the interval from -2 to 4, and we include those values, so we put a bracket around -2 and 4. Now the range, the up and down essentially, right? This up and down interval. So we go from here to here, essentially, that's the range. So the lowest y value would be -4 at this point, and the largest or highest y value would be +2, which is up here. So the range would be the set of y values from -4 to 2, and we include those values, so we put a bracket around them. All right, moving right along, let's look at D. Here we have what's called a parabola, downward parabola, and this would be a function of x because we don't have any x values that are assigned to more than one y value. So function of x, that's good. Now let's look at the domain. Now it's kind of hard to kind of see what's going on here if you never, dealt with parabola or quadratic equations, we say. But this parabola, essentially, goes downward infinitely, and it gets wider. It grows very, very slowly in the horizontal direction, but it would theoretically just keep on getting wider and wider and wider if it gets extended. So the domain would be all the way to the left to all the way to the right. So infinitely to the left, infinitely to the right. So -infinity to +infinity. So the domain is a set of all real numbers. So you could write the set of all real numbers, or you could write -infinity to +infinity, and we put parentheses around them again. Now the range, you have to be careful. The range, we go infinitely downward, because we keep on going downward. But it stops up here. It stops at this point right here. So you go downward like that. So downward, -infinity, since we're talking about the y direction. But up here, the y coordinate is 4, because that would be, that's about -1, 4, it seems. So the range would be the set of y values from -infinity to +4, because the highest or largest y value on this graph is +4. So we put y goes from -infinity, parentheses around -infinity, 4, and we put a bracket around 4 because we're including 4. 4 is included in the graph. Okay, let's look at. All right, here we got this cool looking squiggly graph. And this would actually not be a function of x because you have multiple x values. Here we have an x value of, that's a 3, 3, 0. Here we have a point at 3, 2. And here we also have 3. But as long as we find any x value with more than one y value, it would not be a function of x. So let's first write it's not a function of x. Now let's figure out the domain. So let's actually highlight the coordinates at this point down here. That would be at 4, -3. And this point we already have at 3, 2. So remember, the domain is a set of x values. So again, side to side. So the farthest to the left occurs here, and the farthest to the right occurs here and here, it seems. So we go from there to there, essentially. That's our domain. So this point has an x value of 2. The domain goes from 2, and the farthest point to the right is, looks like that would be 4. 1, 2, 3, 4. So the domain would be the values from 2 to 4. So the interval 2 to 4, and we include 2 and 4, so we put a bracket around both 2 and 4. Now let's look at the range. The range, the up and down interval. So we go all the way up here to down here. So that's our range. And the range would be from this point down here, which is -3, the y coordinate of this point here is -3, and the largest y value occurs here, which is 2. So the range would be the interval from -3 to 2. And we include those values, we put a bracket around -3 and 2. All right, and last one. Here we have a scatter plot, it seems. So let's start off by labeling the coordinates of these points so we can see it more clearly. So that'll be a -2, -4. That's a -1, -1. That's a 4, 1. And this is at -2, 2. Now, this is a scatter plot, we say a discrete graph. And this would not be a function of x because see, we have the x value -2 being paired up with -4 and 2. So it's not a function of x. And now let's write the domain and range. So remember, the domain is a set of x values, and we're not going to write it as an interval because you have gaps between the points. You don't have a continuous line. So instead, you're going to write it in set notation. So we use these Batman symbols, I like to call them, but they're actually formally called braces. They take practice, so practice, I make it look easy, but students struggle with this. So we're going to use this brace symbol, and we simply write the x values as a list. So we have x values of -2, -1, 4, and -2. And we don't need to write -2 again, same, So we're going to put -2, comma, -1, comma, 4, and we close this. And this is our set notation. That's going to be our domain for the x values. And then the range will just be the y values or the y coordinates of those points. And again, we use set notation. So we have y values of -4, -1, 1, and 4. And again, we just write it like a list, -4, comma, -1, comma, 1, comma, 2, close the set with our brace. And there we go. That's our domain and range.